For NuSTAR, we had to do something absolutely unique. Unfold a Tinker Toy-like structure of tens of thousands of piece parts, have it all lock in place, and maintain the separation between the mirrors and the detectors that we needed. And when it worked, I was the proudest, not of myself, but of the whole team, that we had been able to pull this off on a small mission in a way that nobody had ever done before. NuSTAR works in high-energy X-rays, the same energy that your dentist and doctor use because they'll penetrate through your skin and only get absorbed by the dense bone or teeth. Black holes don't live in isolation, they live in regions of dust and gas, and in many galaxies, there's a screen of dust and gas in front of the black holes so that you can't see them, but these X-rays are penetrating, they'll get out through all this dust and gas, which is like getting through your skin, and be detected. And so NuSTAR provides a unique window on these hidden black holes. And we've learned really fascinating things. How fast particular black holes are spinning, X-ray light that is emitted so close that it gets bent and distorted by general relativistic effects. And let us look, if you want, behind the black hole, which is really cool. One of the reasons we designed NuSTAR the way we did was to study the remnants of stars that exploded in the last few hundred years. In the high-energy X-ray, we have a very unique tracer, and that's the radioactive glow from this recently produced material. So one of my favorite images from NuSTAR is the image of Cassiopeia A, which, in low-energy X-rays, are absolutely gorgeous images from the Chandra X-ray telescope. But what NuSTAR added is the very first image of the radioactivity. We could look at the distribution of this radioactivity and say what happened in the explosion itself. And so this really gave us a view of the very core of the star and what was going on in the explosion. NuSTAR looked at a galaxy, and one of our postdocs discovered that this ultraluminous X-ray source was pulsing off and on, off and on, off and on. That means it couldn't possibly be a black hole at all. It had to be something called a neutron star, in fact, a pulsar. The first time we announced this, there was just gasps throughout the whole room. And since then, we found several more, and now the question is, are all of these ultraluminous X-ray sources neutron stars? Are any of them black holes? Well, one of the funnest things we did was something that we didn't tell NASA we were planning to do, and that's look at the sun. Most X-ray telescopes, they avoid the sun because it will damage the detectors. But the way NuSTAR works, we're able to actually look directly at the sun. And so I would say probably my second favorite image from NuSTAR is an image of the sun. That is a composite image, both from NuSTAR and from lower energy X-ray observations. For the first couple of years, the science team planned and executed the observations. But now we're largely in a mode where the whole worldwide community is proposing what it should look at. My hope is that this community grows and that NuSTAR gets used for more and more diverse types of science. And, I hope for another discovery like the ultraluminous X-ray sources, something that we just didn't expect.